part A, we simply have to show that this series here is convergent. So I think we'll use the ratio test, and you'll see that I've just set this up ready to analyse. So if I continue with the simplification, let's have a see what happens. Here we're going to be left with k on the top. Now we've got k factorial over k plus 1 factorial, so that should just leave us with a k plus 1 here. And now we're going to be left here with 1 over k minus 1. Okay, if we continue, we will have the limit as k approaches infinity, and we'll bring this together, noticing it's the difference of two squares, so k over k squared minus 1. If we now divide throughout by k squared, we'll have the limit as k approaches infinity of 1 over k over 1 minus 1 over k squared. And so then as k tends towards infinity, in the numerator we've got 1 over k, which will tend towards 0. In the denominator we're going to have 1 minus 1 over k squared, which will also tend towards 0. And so we're left with 0, which is less than 1, and therefore we should write this down normally, but therefore by the ratio test the series is indeed convergent. For part B, we've got to find the sum of this series. So what I've done is I have taken our infinite series here and I've written it down in terms of partial sums, and hopefully I can find a general term for the partial sums and then look at what happens as n tends towards infinity. So you'll see here I've just found S1, S2, S3, S4, and in fact by this point in time I could see what the pattern was, but just to confirm I've written one more down as well, S5. And what you should notice here is that the denominators of my partial sums are in fact just factorials. So for example, S2 can be rewritten as S2 equals 1 over 2 factorial. S3, well, the denominator is certainly 3 factorial, and so on the top what we can say is that it is 3 factorial minus 1, and S4, following the same pattern, we can hopefully see it is 4 factorial minus 1 over 4 factorial, and this one here is going to be 5 factorial minus 1 over 5 factorial. That allows us to make a generalization and say that Sn will be equal to n factorial minus 1 over n factorial, which we can then simplify by breaking it up into two separate fractions as n factorial over n factorial minus 1 over n factorial, and so in fact Sn is equal to 1 minus 1 over n factorial. And all we now need to do is to find the limit as n tends to infinity of this sequence of partial sums. So the limit as n tends towards infinity of Sn is the limit as n tends towards infinity of 1 minus 1 over n factorial, and it should be very clear to see that's going to be 1 minus 0, which equals 1. So the sum of the original series will be equal to this limit, and so therefore the sum of the series is simply 1.